Hello, I am Nate Croft from the Healthcare Solutions team at NetApp. This video will be a demonstration of the use of NetApp's SnapCreator framework software with an Intersystems Cache database. We have developed a plugin for SnapCreator that integrates the software with Cache to enable database-consistent data protection and management. First, what is SnapCreator and how does it work? SnapCreator is NetApp software that integrates NetApp data protection features with third-party applications when application and/or database consistency is required. It is a centralized management solution that can be used to automate, schedule, and manage backup policies in an integrated environment. SnapCreator works by having a server which hosts the user interface initiate commands to an agent running on the application host. The agent maps SnapCreator actions to operations for the specific application. The server can then coordinate data management between the application and the NetApp storage that hosts application data. In this demonstration, the SnapCreator server and agent interact with Cache to enable database-consistent backups of Cache databases. SnapCreator is able to integrate with specific applications by utilizing plugins that can be installed alongside SnapCreator. The plugins are application-specific and require no customization. They provide tested, easy-to-use integration. We have developed a plugin that integrates SnapCreator with Cache. The plugin enables SnapCreator to perform database-consistent backups of a Cache database by specifying operating system cache management commands. This provides automated workflows from the SnapCreator management interface, even enabling other SnapCreator features such as snap mirrors or flex clones. Installation of the plugin can be done by simply copying the plugin file into the SnapCreator agent directory on the Cache host. In this video, I will demonstrate creating a backup configuration that uses the plugin to create a snapshot copy. I will also demonstrate an optional data restore method that the plugin can enable. First, let's walk through the backup workflow step by step and look at an overview of our demonstration environment. I've installed the plugin and Cache on a Red Hat host, and I am running SnapCreator through a Windows host. The SnapCreator server can run on Unix as well and could run on the same host as Cache and the agent. Connected by fiber channel to the Cache host is a NetApp storage cluster that houses the data in a sample Cache database. To demonstrate a backup, I will take a snapshot copy of the database by triggering a backup action from within the SnapCreator GUI. SnapCreator will first quiesce the Cache instance controlling the database by giving the Cache-specific external freeze command to Cache. Then, while Cache is quiesced, the SnapCreator will trigger the creation of a snapshot copy of the storage volume that holds the database. Once the snapshot is created, SnapCreator will unquiesce Cache, giving the external thaw command, which returns Cache to normal operation. With this workflow, SnapCreator takes a database-consistent backup without disrupting the operation of Cache. So let's do a backup. What I'm showing you now is a view of the Windows host with SnapCreator GUI open. I will log into SnapCreator, and from here, I will need to create a SnapCreator configuration that holds all of the parameters of my environment that SnapCreator needs to work. It has a handy wizard that will walk us through this process. I select this Red Hat server profile and right-click to add a new configuration. I'm adding a configuration for Cache, so that's what I will call it. And the wizard then asks me to select the plugin type. Cache is a community plugin, and I select that. And as you can see, for configuration setup, the Cache plugin is already integrated into SnapCreator. I can select Cache right from the wizard, and it prompts me for Cache-specific information. The plugin itself is not a part of SnapCreator install, but work was done to allow SnapCreator to easily use the plugin that was written for Cache. So I enter the information that is specific to my Cache installation. The system path is a Windows-only parameter. I don't need that. Instance name is Cache. I've done the default. Username, I'm using the default username. I will turn on verbose feedback, and I will tell Cache to switch journal on freeze. Then I need to establish communication with my SnapCreator agent. I insert the IP address of my Red Hat server host, and as you can see, the agent is running. Then I follow the steps through the rest of the wizard. We are using clustered data on tap, and the wizard prompts me for the vServer information in my storage cluster. With a vServer specific user. All this integration into clustered data on tap is done through the SnapCreator framework side of things, which makes it very easy to integrate Cache into the latest versions. Once I've entered my vServer information, SnapCreator will show me a list of all the volumes on my storage cluster, and I will select the specific one that has my sample cache database. Click Save to include that in this configuration. And at this point, I can start setting up my storage policies. So I can include details for what the snapshots that I want created by this configuration to look like. We'll call this, we'll name the snapshots Cache Demo. You can enable different storage policies here, from hourly, daily, weekly, and so forth. I'm just going to enable daily, and I'm going to retain one at a time. This could be up to the administrator to set up whichever policies they like. There's lots of options here. I'm just going to accept the default. But all of these options are available through the SnapCreator framework for managing backup policies. Again, I'm going to accept the default. We could set up a SnapMirror relationship, but we're not doing that for this demonstration. And we are not using on-command settings. Finally, SnapCreator gives me a summary of all the information that I've included in this configuration, which looks good. I finish, and it creates a configuration. Once the configuration is set up, I can create a backup copy right away. I can go here, I can select my cache configuration, and it's ready to go. As you can see, all of the settings and parameters that I've input are part of this configuration. There's even a tab specifically for cache, where if anything changes within my installation, if new username or anything like that, I can make those changes right here and save them to the configuration without going through the wizard all again. To create a backup copy, I could just go to Actions, Backup, and SnapCreator will run. I select the daily policy that I enabled, and I will pull up the console so that we can watch the log as SnapCreator works. If we go down, first you can see that SnapCreator has called for an application quiesce, and it's quiesced the instance of cache, and we've got an output back from cache that yes, the quiesce is finished successfully, the journals were switched. SnapCreator then triggers the snapshot copy. Snapshot copy has been created on the volume that we included in the configuration. And finally, SnapCreator unquiesces the application. It is unquiesced instance cache, and that has finished successfully. Now, as part of the plugin, it reads return codes from cache so that you can be assured that when it says it's finished successfully, that is because it has gotten the successful return code from the cache instance. But for this demonstration, I will show you that yes, in the cache portal and the cache logs, we can see that a quiesce and unquiesce did in fact happen. So I'm just going to log in to my cache management system for the cache instance that's on my Red Hat host. I can go to Menu, View Console Logs, and if I go all the way down to the latest log, you can see that yes, indeed, external freeze was triggered, the system was suspended, and about 20 seconds later, external thaw was triggered and the system was resumed. In between that time, our database consistent snapshot copy was created. Once we've enabled database consistent snapshot copies, that enables a large part of Snap Creator functionality. We can set up Snap Mirror updates, we can do clones, and start scheduling management policies, user policies, schedules for when snapshots could run. All that is now enabled just by creating that configuration. The plugin also has an optional feature that automates data restoration. I will demonstrate this next, which will also use the snapshot copy that we just created. To demonstrate the optional restore method, first I will need to make changes to a sample database, which I will do from the Snap Creator host. This will modify data on the storage volume, at which point I will have a current working database and, from the snapshot copy, a viable and consistent backup of the database's previous state. To restore the database with the optional method, the plugin and Snap Creator automate a workflow. In order to restore a cache database, cache must be stopped, then restarted. In this workflow, Snap Creator stops the cache instance, then triggers a volume restore on the storage cluster, which instates the snapshot copy as the working volume for the database storage. Snap Creator then restarts cache. At this point, the sample database will be restored to its previous state. I will point out here that this is an optional feature of the plugin. Some production environments will have specific plans for handling data restores, and so this feature is disabled by default. By default, Snap Creator can be used to restore the volume on the storage, but it does not interact with the cache during the restore, as I've shown here in the optional method. This leaves cache manipulation to the administrator's discretion. But this feature is useful in this demonstration and may be enabled for appropriate environments. To demonstrate the optional restore method, I will first make changes to the database stored on the NetApp cluster. I've created a link to it, and I will open that up and delete entries from the database. I navigate to the sample database in cache and will select the person file. As you can see, this is a database that has about 200 entries of different people and their information, and it goes incrementally, 1, 2, 3, 4, all the way up to 200. For this demonstration, I will select rows 4 through 20 and delete these entries from the database. At this point, rows 4 through 20 are missing from the database. They're no longer part of what's stored on the database storage in the database file. Once they're deleted, I can go to Snap Creator and select Restore to restore the information that I've changed. With the restore method of the plugin enabled, all the actions required to restore the data to its previous state are automated to get it up and running again after the restore. There's a wizard in Snap Creator, again, that guides me through all the information that I need to input. I select the appropriate vServer, the volume that I want to restore, the snapshot policy that I want to restore from. This is the snapshot that we just created a few minutes ago, and the restore type, which I want to restore the entire volume, as the cache database is the only thing on that volume. I hit next, and Snap Creator gives me a summary of the information I have input. That looks good. Finish. And Snap Creator just gives me a reminder that once we do a restore, any data that has been changed since the last snapshot copy will be lost. That's correct. That's what I want to do. So I select yes, and Snap Creator starts to run on its restore workflow. As we go through, we can watch as the Snap Creator actions are taking place. First, the pre-restore handling for the plugin. It stops the cache instance. We get the correct return code, and so the cache has been stopped. Finally, next we restore the snapshot copy of the volume. So we have restored the volume to its previous state, and after the restore, we go to handling for cache. It starts cache, and we get our feedback back that yes, cache is starting up, and it has started successfully. So with that quick automated workflow, we can open up and reconnect right away to our cache database, go back to the sample database, sample.person that we selected before, And as you can see, those entries that we deleted, rows 4 through 20, are back and working in this database. So with that optional restore method, it was a quick, simple, automated workflow for restoring a cache database. That concludes the demonstration. The plugin we have developed integrates SnapCreator with Cache, enabling consistent backup management through the SnapCreator interface. It is already integrated with clustered data on tap and works on the latest version. The plugin is a community plugin available for open access on the NetApp community GitHub, where the code can be viewed and used by developers to add or customize the plugin methods. For NetApp partners, we will also publish an updated technical report that details the use of the plugin in depth. The plugin is currently tested on Red Hat 6 and SLES 11 with clustered data on tap, and testing for AIX is currently planned. The framework, SnapCreator framework itself, is supported by NetApp support, while community plugins, the type that the SnapCreator plugin for Intersystems Cache is supported by the community. That concludes the demonstration. Thank you for following along with this video. For more information, please visit the links provided.